In this video, we find the sum of the first n terms of an arithmetic progression. Now, when all the terms of an AP are added, we have an arithmetic series. To understand how to add the terms in this arithmetic series, let's look at a simplified picture of adding the numbers from 1 to 100. We know that the series from 1 to 100 is an arithmetic series with common difference being 1 and the first term as 1. When we write the numbers from 1 to 100 and add them together in the forward manner, we get equation 1. And if we choose to write the numbers in the reverse order starting from 100 at 99 and 98 all the way up to 1 in the reverse order, we get equation 2. Next, what we do is we add two numbers correspondingly this way. Now we will see that on the left hand side we will have 2s, s plus s. Then on the right hand side, 1 plus 100 give us the first 101. 2 plus 99 give us 101 again. 3 plus 98 again give us 101. And this proceeds on all the way to the last pair of numbers. 100 plus 1 again give us 101. So every pair of numbers that we add together from the two series from equation 1 and 2 will generate 101. How many 101s do we have? We know that we are adding 100 numbers for s. So all in all, we should be having 100 101s, which means 2s equal to 100 times 101 times 100. Therefore s must be 101 times 100 divided by 2. That gives us 5050. Now we will next look at the more general term Sn, sum to the first n term of arithmetic series. It's the same idea. We let our first term be a, therefore second term will be a plus d, third term a plus 2d, and we let our last term that we are trying to add be the nth term u subscript n, which means the second last term of the AP will have to be un minus the common difference, so un minus d. The third last term will be un minus d again, so we get un minus 2d. Adding this up will give us equation 1. Next, we write all these terms in the reverse order for Sn again. Left hand side is Sn. For right hand side, we will reverse the order, starting with un. Now, second last term un minus d has been switched to the second place in the front, and so on and so forth. Now you can also see that the a in the original first series has gone to the last term in the second series. So after writing in this manner, we will start adding the terms in the two series in pairs like this. On the left hand side, when we add the two Sn's together, we get 2Sn. On the right hand side, the first two terms added give us a plus u subscript n. The two second terms added up will again generate a plus u subscript n, because the two d's, d and negative d, will cancel out. For the third pair, we find that the 2d and the negative 2d cancel out, and we again get a plus un. This goes on until the last pair, which of course gives us our last a plus un. Now, how many a plus u subscript n do we get? We know that we are adding how many terms here? N terms. Because we were finding the sum of the first n terms of the AP. And therefore, we of course have n of a plus un. So, the highlighted part shows our result. Dividing by 2 on both sides of the equation will generate this very useful sum to n term equation formula for an AP. Now we must recognize that the questions can be set in different manner. We may not be told what the last term is, the last term that we need to add up, we may not be told. But we do know that the last term can be written as a plus n minus 1d. Thus, if we substitute this into our earlier equation obtained, we find that we will obtain within the square bracket 2a plus n minus 1d. So our Sn has two different formula. Depending on the situation, if the last term to be added is given, we will use this first form that's highlighted in yellow. But if we are able to deduce the values of the first and common difference, we can use the equation highlighted in green. Now that's the end of this video. In the next video, we will be exploring how we can apply these equations that we have obtained. Thank you.